All right, so today is chapter 9, section. Let me just mute everybody real quick. Chapter 9, section 3, truth tables. All right, so truth tables, we're going to be taking what we have learned with our connective, our logical connectives, and we're going to convert them into a truth table. And a truth table is a more concise way to see if what you are looking at, what you're talking about, is true or not, right? Does the logic check out? Let's see. All right, this is kind of what we talked about last section, but I guess we can just go ahead and snip it. Alrighty, so negation, we talked about negation. It's a little tilde, a little squiggle there. So the negation of a true statement is false. That makes sense, right? And then the negation of a false statement is true. And again, these are things that you know, obviously, but it's also things that we're going to be using moving forward. Right? Now, truth tables, I I don't feel like truth tables are abundantly difficult. Especially once you realize how to create them. Once you create them, you can begin the process of solving all sorts of logical problems. All right, so we've talked about conjunction, the and symbol. Let's see. There we go. Okay, so the caret up, facing upward, right? The and symbol. We've talked about that. And in order for something to be a true statement, right? So if we have P and Q, then we know that both statements must be true. All right, so in this particular example, we have I visited London as P and Q as I visited Paris. All right, for P and Q to be true, so that means if we're going to make a table, we have a table is going to end up looking like this. Right? So this is just the first top part of the table. If we say P as I visited London and Q as I visited Paris, right? So if my friend visited London and I visited Paris, well, I'm sorry, if I visited London and I visited Paris, then it's true that I visited London, it's true that I visited Paris, and therefore it's true that I visited both. Right? Well, if it's true that I visited London, again P, and it is not true that I visited shoot, I messed up Paris. So it's true I visited London. It's not true that I visited Paris. Then this statement here is false, right? Because both both um, statements must be true in order for the P and Q to be true. And of course, we can see that over here as well, right? So if it's false that I visited London, but it's true that I visited Paris, well, this is a false statement. P and Q is a false statement because one of those two are false. Right? In order for the P and Q to be true, then both P and Q must be true. And of course, we see lastly, if it's false that I visited London, false that I visited Paris, and obviously it's false that I visited London and Paris. Okay, so in order for a conjunction to be true, then both statements P and Q must be true. They have got to be true, and we see that down here. And I think that this is a good point to put a star on because it's very important. Right? Excuse me. A conjunction is true only when both simple statements are true. All right, so next up we'll talk about disjunction. Now disjunction only needs one statement to be true. Right? So going off of the P being I visited London and Q being I visited Paris. Looking at this truth table, if we have an or, right, the disjunction, the or, then only one of those two statements must be true in order for the disjunction to be true totally, right? So obviously if it's true that I visited both, then the disjunction I visited London or I visited Paris is true. If I visited London but I didn't visit Paris, well, the statement's still true. If I did not visit London but I did visit Paris, the whole statement is true. The only time it's false is if neither statements are true. Right? So this is another place where you're going to put a star. A disjunction is false only when both component statements are false. So it's kind of in the same vein as the and. The conjunction is true only when both simple statements are true. It's kind of like that, except in this case, it is false only when they are both false. Okay, so let's get to the fun part. The actual, well, this isn't an actual truth table. We're not at the fun part just yet. All right, so example 1 reads, let P and Q represent the following statements. P is going to read 10 is greater than 4, and Q is going to read 3 is less than 5. We're wanting to determine the truth value for each statement. So A is saying P and Q. Okay, so P is 10 is greater than 4, and and 3 is less than 5. All right, in this particular statement, they are both indeed true. So this is going to be a true statement. That's a terrible T. That looks the same. Whatever. All right. B's where, so if A kind of confused you, B might help clear things up. So if we have not P, so not P is going to be 10 is not greater than 4. Okay. 10 is not greater than 4, and we have Q, which is 3 is less than 5. Okay. Well, by looking at this particular statement, looking at this says 10 is not greater than 4. Okay, well, that is obviously a false statement, right? So this is a false statement, and we have the and connective there. Well, in order for a true statement with an and connective, going back, right, right here, then both statements must be true. Okay. Well, since the 10 is greater than or equal to 4 is a false statement to begin with, then this entire problem, this entire B is going to be false because 10 is not greater than 10 is not greater than 4 is a false statement. Okay. So in both these examples, both conditions must be true in order for it to be true. Right? And in an A, P is a true statement and Q is a true statement, and since there's an and connective, then they're both true. And let's do it this way. Let's really drive the point home like this. So we've got P and Q. All right. P is a true statement and Q is a true statement. So therefore, it's going to be a true statement. B, and let's just go ahead and take all the space down here. We have not P and Q. Okay. Well, again, not P is saying 10 is greater than 4. That means it is not true. So 10 is not greater than is not greater than 4. But we know that's a false statement. So we can say this is false. Okay. And then we have and then Q is obviously a true statement. But since one of those two is a false statement, this means the entire statement is going to be false. So since looking at the first two problems, it was an and connective, so they both had to be true for the entire statement to be true. Well, we're about to do C and D. Okay, they are an or statement, so only one of them must be true in order for this to be a true statement. So C, we've got P or not Q. Okay, well, P again is an obviously true statement because P is 10 is greater than 4, which is true. Or, well, not Q. So Let's go back. Let's examine Q. Q is 3 is less than 5. Okay. If we were to make it a not statement, we would say 3 is not less than 5, which we know is a false statement. We know that's going to be a false statement, right? Because 3 is less than 5. Well, we have a true or false, but since it's an or statement, it makes the entire statement true because only one has got to be true. Unlike A and B, where both had to be true, for C and D, they both must be true. And of course, we have not P or not Q. Okay. Well, not P, again, not P is going to be 10 is greater than 4, not that. Okay. Well, we know that's a false statement, so we can say false. And then or, well, not Q. Again, the same vein here, not Q. So if Q is 3 is less than 5, if we said not Q, we know that's also a false statement. Okay. Well, both of these statements are false, and in order for the or statement to be true, only one of them must be true. But since they're both false, we end up with a false statement. So again, quick recap, because we're going to be using this thought process a lot moving forward. If we have the and statement, the and here, then they both must be true. Both statements, P and Q, they both must be true in order for the and statement to be true. Of course, in B, we see a false and true, but since they're both not true, we have a false statement. They both have to be true. Well, for an or statement, only one of them has to be true, just one. And if one is true, then the statement's true. And of course, in D, both are false, so the statement was false. We're going to be using that for the rest of this section. All right, so in order to construct a truth table, luckily it's not something that you need to really wrap your mind around to try and memorize, because it's just basically every single I say every single, all four of these possible options. And we'll go over that here in a second. So before we begin, we know that we've talked about the negation symbol, right, which means not, right? The negation of a statement has the opposite truth value from the statement. So if we say it is raining outside and we put a negation on it, then we're saying it is not raining outside. Conjunction, what we just did, again, A and B in example 1, what we would do is they both have to be true in order for the statement to be true. If we have the conjunction, if we have the and, they both have got to be true. For the disjunction or the or, only one of them has to be true. Right? So constructing a truth table, we're every single truth table with two statements. Right? So this is only with two statements, P and Q. Every single truth table you're going to make is going to start out like this. Right? And that's exactly how we're going to begin every single truth table with two statements for this lecture as well. Right? And of course, all this is just kind of telling us what we need to do, but again, words don't mean too much. Examples mean a lot more. So let's construct a truth table for example 2. Oh, real quick, before I do construct that truth table, I said every single truth table is constructed like this. No, we just go true, true, false, false. Okay, true, true, false, false, down the P column. And then we just combine it with something that, we combine it with true, false, true, false. Now again, you can memorize true, true, false, false, and then true, false, true, false. Or you just know that we're wanting a combination of true and false, right? We have both true, we have both false. We have P is true, Q is false, and P is false, Q is true. These are the only 4 combinations that you can possibly have. Now, I say this is how we construct truth tables. If by some chance, you happen to do truth, true, and then false, false, and then the others, it doesn't really make too much of a difference because at the end of the day, we're just talking about logic here. So logically, you are still on the same path. It's just pretty sure the tables in your homework are also constructed like this as well. So let's begin the truth table here. So before we begin, well, let's just read it. So it says construct a truth table for, and we have not, the entire statement not, P and Q, to determine when the statement is true and when the statement is false. So like I said, we're going to construct a truth table. So we're going to say P, Q, and let's try this. We'll try, actually I think this might get out of hand pretty quick, but we'll try it anyways. Okay, so we've got true, true, false, false, and then true, false, true, false. Okay, so this is how we begin every single truth statement. I'm sorry, truth table. I know I have a square tool. Where's it at? Maybe I'll use it for the next one. All right, so I have to make the. I'm going to go according to the. I should have just made the whole box huge to begin with. If you recall from the previous section, we have, kind of an order of operation here, right? The first order is I need to get what's inside the parentheses. So what I'm going to do is I'm going to create a column called P and Q. Okay, so this is the column P and Q. Well, if you recall from the previous examples, in order for P and Q to be true, then both of these must be true. Okay, so obviously we see here that we have true, true, therefore this is true. We have true, false, therefore this is false. We have false, true, therefore this is false. And we have false, false, which is obviously going to be false. Okay, so that was that part. That was P and Q. Next up, what we're going to do is we're going to make, and my goodness, I really should have just made this a big old box. Sorry about that. Next we're going to do is we're going to make a not P and Q. Okay. Well, not P and Q, if you recall, is just going to be the opposite of this column. Okay, it's not. It's the negation of it. So since we have a true here, it's going to be a false here. False here, true here. False makes this a true, and false makes this a true. Okay, so this says that determine when the statement is true and when the statement is false. Okay, well, the statement is true. The statement's going to be true whenever P is true and Q is false. Whenever P is false and Q is true. And then when P is false and Q is false. All right, that will be the only times that this statement will be true. And I believe it's kind of a worded example. Yeah. So just kind of a word example to put meaning to the P and the Q. If we were to have P be Harvard as a college, and we have Yale as a college, which is true, right? But both are true, so that would be P and Q, right? The statement not P and Q translates as it is not true that Harvard and Yale are colleges, right? Well, obviously that is going to be a false statement. It is true because it's a false statement because it's true that Harvard and Yale are colleges. So this is how we construct the truth table. And again, we're going to do, I think, like 5 more of these, maybe at least 4. All we do, like I said, to start off, we have P and Q. We just start with this entire, these 2 columns, right? Everything in yellow, you're gonna write every single time. And then what you're going to do is you're just basically going to be adding columns in based on what the statement is asking. And more examples will probably really help drive the point home. right, real quick, I'm going to check this out, see how far I need to make. 1, 2, 3, so 3 more columns. So yeah, I'm just going to make this a big old giant box, and I know I've made a square on here before. I don't remember how, though. Huh. Oh well, I guess we're just going to make a square. Oh, is it this? No, that's not it. Hmm. Well, heck, I don't remember. Alright, so let's just make the whole square here. We'll just erase what we don't use this time instead of adding on. It's a horrible square. Alright, so we're going to have P and Q. And again, we're going to start off with the exact same way that we start every single truth table. We're going to just write true, true, false, false, and then true, false, true, false. Okay. All right. So looking at the problem here, we need to figure out what not P is and what not Q is. Well, all we have to do for that is we're going to write not P. Right. Well, not P is just going to be the opposite of these. Okay. So it's true, true, false, false. So the opposite of that is going to be false, false, true, true. And then we're going to do the same thing with not Q. Again, looking at this column, it is true, false, true, false. So the opposite of true, false, true, false is going to be false, true, false, true. Right. Now we can do the entire statement here, which is not P or not Q. So we'd say not P or not Q. Okay. Well, when we do not P or not Q, we're going to just look at, we're just looking at these columns now. Okay. And if you recall, in order for the not statement to be true, only one of these must be true. Okay. So looking at the first row, well, it's false, false, right? False, false. So therefore, this must be false because there's no true involved there. Okay. Well, we have false, true, and since we have a true, then that's going to be true. And then since we have a true here, that's going to be true. Well, that's going to be true. And then since both these statements are true, then this is obviously going to be true. All right. So we constructed our truth table. So now we can do some erasing here. And we can answer this question. Right. The question being asked is to determine when the statement is true and when the statement is false. Alrighty. So the statement's going to be true whenever P and Q, whenever P is true and Q is false. So it's going to be true when P is true and Q is false, when P is false and Q is true, or when they are both false. That is when the statement will be true. The statement will be false when both P and Q are true. So hopefully these last two examples really drive the point home of the truth tables. They're not abundantly difficult, especially if you understand the negation of them, and of course the and or the or. Right. This particular problem looks a little more complicated, and we need to figure out when the statement is true and when the statement is false. So like I said, we're going to start this problem like we start every single one. We're just going to make a big old square. We're going to have P, we're going to have Q, and we're going to do the true, true, false, false, and then true, false, true, false. Alrighty, so just like we talked about in the previous section, we need to be able to group these according to our actual statement, right? But before we actually do that, we need to figure out what the not P is and what the not Q is. And we don't have to figure out what not Q is, but we will anyways, right now. We probably could have waited on it, but we're just going to hit it right now. So we have a not P and we have the not Q. Okay. So not P is, again, just going to be the opposite of P. So instead of true, true, false, false, we're going to have false, false, true, true. And then the opposite of Q is going to be false, true, false, true. Right. So next up, what we're going to do is we're going to look at, we're going to finish off this statement here. We're going to look at not P, here we go, not P or Q. So we're going to write that up. So we're going to say not P or Q. So not P or Q is going to be this column and this column. Okay. So what I need to do is my connective statement here is an or. So I'm only going to be looking at the columns where we have a true statement. Okay. So if we looked at those two columns, this is true, and this is true, because only one statement has to be true in order for not P or Q to be a true statement. So we can write this as, so we have true, false, true, true. And again, just to recap, I'm looking at these two, and since it's an or statement, if one of these is true, then the entire statement is true. And of course we see that here, true, true, true. Right. And then lastly, we can finish this off with what the entire statement is actually asking, which is not P or Q and not Q. So what I'm going to be looking at now is I'm going to be looking at this statement, because that's this right here, as well as the not Q, which is this one, because I'm wanting not Q. And since I'm wanting an and, or since it's an and statement that I'm looking at, then both statements must be true in order for this to be true. Okay, and if I look at this, well, this is not Q is false, and then not P or Q is true. So I have false true, I have true false, I have false true again. However, this last one, they're both true. So we're going to say this is false, 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 and then true, because these two statements are true. Right? And what the question was asking was determine when the statement is true and when the statement is false. Well, the statement is true when P is false and Q is false. Right? So when P is false and Q is false, the entire statement is true. And obviously, when the statement is false is every other time, right? Whenever we have both of them are true, when P is true, Q is false, and when P is false and Q is true. And in case you're wondering, in words, it's basically the exact same thing as what I said. It's just, instead of having a truth table, let's see, where's my shoot. The truth table is not complete. By looking at the truth values in the last column, we can see that the compound statement is true only in the fourth row. That is when P is false and Q is false. And of course, we covered that where we said that here when they're both false in the bottom left. All right, so next up we're going to talk about a statement that is always going to be true. Okay, so this one seems pretty easy, right? It's P or not P. Well, uh, my only options, all right. So if I were to try and construct this big old huge table like I normally do, right? I would put a P here. Normally I put a Q here, right? But I don't have a Q. Instead I have a not P. Okay. Well, the truth table here is, about as easy as it gets, right? P can either be true or false, right? Well, the opposite of true or false is going to be false or true. So this is it for the truth table for this particular problem, right? But the concept of this problem is not done yet. So it reads, construct a truth table, which we just did very, very quickly, right? Well, actually, we didn't complete it. We just did the first part. All right, we need to determine when the statement is true and when the statement is false. All right, so we need to figure out what P or not P is. Well, again, it is an or statement, so I only need a true statement in either row for it to be true. Well, this is true, and I have a true here, so this is true. So it looks like, in this particular case, that they are both true, right? This is an example of what's called a tautology. A tautology is a statement that is always true. No matter what, it is always true. And put that up here. And we're going to be using a tautology later in this section of a statement that's always going to be true. All right, now we're going to get to something a little tougher, and this is just with getting a truth table with 3 statements. And the way we do that with 3 statements, if we look down here, we have P, Q, and R. And again, it's just the way you set it up is just you have a logical conclusion based on what we did with P and the Q, right? We did every single combination of true and false. Well, that's what we're going to do here. Is we're going to try and get every single combination of P, Q, and R. And there are 8 combinations because I can't remember if we talked about it in this class, but since there are 2 possible outcomes, you say 2, and we have 3 statements, that's 3, so it's 2 raised to the 3rd power, which is 8. And so that's why we have that. There will always be 8 of them. And of course, if we have 4, we'll have 16, and so on and so forth. But the way we construct this, and for the record, I don't memorize this either. I basically just say, okay, so I do true, 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 and then false, 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 false. And then from there, I just build it. I build up my truth table. So I don't know, that's about all the pro tip I got for you on that front. But we use a truth table with 3 statements the exact same way we do it with 2 statements. It's just now that, there's a little bit more work, but there's not much to it after that. So let's do this. And I'm going to have to write this a lot smaller this time. Was it this? I know I've made a box before. I just wish I knew how I did it. Oh well. All right, so we're going to have to make a big, long box. Maybe I'll just do it this way. That's not terrible. All right, so we're going to have a P, Q, and R. We have to have 8 of these. Let's see, P and Q. So 4, 5. So it looks like we need 5 of these. Well, if anything, this actually looks a lot better than the lines I pretended to make a moment ago. So we do have that going for us. This is actually going to look really nice. All right, cool. Alrighty, so start from the top. We need to construct a truth table for the following statements. I study hard and ace the final, or I fail the course. Alrighty, so what we need to do is we're going to use the P, Q, and R, and we're going to denote P as, let's say I study hard. So P is going to be I study hard. Study hard. PQ is going to be I ace the final. Looks awful, but that's just the way it is. And then R is going to be I failed the course. Okay, so these are my statements. P is I study hard, Q is I ace the final, and R is I fail the course. So we're going to, again, construct the truth table. So P, Q, and R. And again, I notice we're going to go true, 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 false. And I done ran out of room. Okay, so let's try that again. Got to make these a lot smaller. Okay. And then I know Q is going to be true, true, false, false. So true, true, false, false, true, true, false, false. And I guess that's a good pro tip for the first two columns. And then, let's see, what did we didn't actually say it. Okay, so let's see. And then we have what? True, false, true, false, true, false, true. Oh, that's actually pretty easy to memorize. So true, false, true, oops, it's supposed to be a false. Whew, all right. So I constructed my P, Q, and R on this table. So A, we're still working on A, says construct a truth table for the following statement. I study hard and ace the final, or I fail the course. Alrighty, so in order to do that, so let's make this A, if I were to set this up as a statement, it reads again, I study hard and ace the final. Okay, so since I'm going to be studying hard and acing the final, which is Q, and then we have the, if you recall on the previous section, we have this comma here, right? The comma is right here. Hopefully you can see it, which means that we're going to be connecting P and Q together. And then we have or I fail the course. So or R, or I fail the course. Okay. So in order to make this, in order to fill in this truth table, right, we look at the statement here. Well, we've already got the R taken care of, right, which is this column. We've already got the R taken care of. So what we need to do is we need to make a column for P and Q. So this is where I was talking about, it's not too much different than what we did previously. It's just there's honestly there's more work to it. P and Q. So again, in order for P and Q to be a true statement, then both P and Q must be true. And those are the only true ones, right? Because we have a false here, false here, false here, false here, false here, false here. It doesn't matter, right? They both must be true. So it's only the top two that will be true. So let's put that down. True, true, and then the rest are false because, well, that's the and connective we talked about a moment ago. And then lastly, we can figure out what the actual entire statement is, right? The entire statement, it was P and Q or R. So now I'm going to be looking at this column for the P and Q, and then we have or R, right? And then or R, which is this column. Well, again, in order for it to be a true statement, I only need one of these rows to contain a true statement. Well, if we look at this row contains a true statement, this row contains contains a true statement, then honestly, I feel like all of them except for one. Well, I guess, no. Yeah. So the ones I circled, are the ones that contain a true statement. So that means that I can put a true where those are. I'm going to erase that because it's a bit of an eyesore. But we have true here, true here, true here. This is false. We have a true here, false, true here, and this is false. Okay. So we completed A. We constructed a truth table for the following statement. Now going on to B, suppose that you study hard, you do not ace the final, and you fail the course. Under these conditions, is a compound statement in part A true or false? Okay, so this is pretty easy because all I have to do is look at my truth table. So this says, suppose that you study hard, okay? So that means P is going to be true. So it's going to be one of these. So I'm going to study hard. You do not ace the final, so it's going to be false. So Q is going to be false, so it's going to be one of these. Okay, but we know it's not going to be these because, well, it has to be one of these four up here. And then lastly, excuse me, and you fail the course. So if I fail the course, then that means that it must be, that that means R is going to be true. So it's going to be one of these. True, 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 true. All right. Well, only one of these rows, again, rows are sideways, only one of these rows have all three of those that are true. Right. So it is true that I study hard. It is false that I ace the final, but it is true that I fail the course. All right, and if I just follow along with my truth table, I see that that statement would be true in the end. And again, there's lots of drawings and circles I did everywhere, so I'm going to erase all that so it looks better on the notes. Instead, what I'm going to do is I'm going to say for B, it's going to be true, false, true, and then that makes the entire statement true. Whew, that's a mouthful. All right, and then lastly, we have at the very beginning of the book, I'm sorry, the section, we talked about pretty people and they what was it? They make more money? I forget. But let's try to construct a truth table from that. Right. So up until this point, we have seen truth tables in an abstract way. An abstract way meaning P's and Q's. Well, now let's go ahead and try this with actual words, with actual real life examples. So looking at this graph, all right, this graph shows the distribution of looks for American men and women ranging from homely to strikingly attractive. Right? So use information in the bar graph to determine the truth value of the following statement. What we're going to do is we're going to figure out if this statement is true by constructing a truth statement, right? Now, for the record, if I were to read this, it is not true that 1% of American men are homely and more than half are average, or it is not true that 5% of American women are strikingly attractive. Me reading that statement, me with many years of mathematical experience, I don't know, right? I don't know if that's a true statement or not. And this is where truth tables come into play. Truth tables help organize your thoughts and logically deduce if this is a true statement based on the information. But just reading that as a sentence, I'm so lost, right? So we need to figure out a truth statement here. So instead of creating a chart like we did here, this big old huge chart, instead we're gonna attack it a different way, and in a way that well, it's kind of quicker, right? So first of all, let's go ahead and write the statement. So the statement says it is not true that 1% of American men are homely and more than half are average. So what we need to do is figure out some P's, Q's, and R's, right? Because there are three different statements here. So instead of me writing it in cursive like I always do. Let's just go ahead and type it out because I think I have to type a lot more this time. Okay, so P is going to be 1% of American. It's not true. 1%. Okay, so 1% of American men are homely. Q is going to be then half of American men are average looking. And then R is going to just be 5% of American women are strikingly attractive. Okay, so these are my P's, Q's, and R's. So if I were to try and write this with my logical connectives, I would say it. Okay, so reading off, it is not true. So it's going to say not true, right? And on top of that, again, remember to always mind your comma there. Okay, so we're basically going to put this bit in parentheses, and then we're going to have the or, and then the not true that 5% of American women are strikingly attractive. So we're going to say it is not true, so that's going to be not true, that 1% of American men, so we'll say P, are homely, and, so we have the and statement, so we're going to say the and then Q. Okay, so it is not true that 1% of American men are homely and more than half are average. So this takes care of everything before the comma. And now we have the comma, so we're going to say or it is not true that 5% of American women are strikingly attractive. So we're going to just simply say not are. Right. So this is what we built up, and now we're going to be looking at the graph. Okay. So we're going to just start here. We're going to say not, and then we have P. Okay. So P was the statement 1% of American men are homely. And if we look at the graph right here, right, men are the orange and women are the yellow, then it looks like it's a true statement, right? 1% of men are indeed homely. So we're going to put a T there because it's true, right? Then we're going to have an and what? Q, more than half American men are average looking. So we're going to go over here to average looking. And again, 59% obviously is more than half, so this is also true. Okay. And then we see we have ourselves a tautology. Then we have or, and then not, and then R is 5% of American women are strikingly attractive. Okay, so we go to strikingly attractive over here in the yellow. It's 3%, right? Well, R is the statement saying 5%, but on the graph it says 3%. So this is going to be a false statement. And then from here we can just follow along our negations and then the ors and figure it out. Well, we know that this, as mentioned a moment ago, is a tautology, right? It is that both statements are true, right? True and true, so therefore it's going to be a true statement. So we're going to have a not, and again, that's on the outside of the parentheses pretty much, and then not true. And then we have or, and then we have not false. Okay, well, let's go ahead and take off the parentheses on the not true because, I mean, it's not necessarily needed anymore, right? So we're going to take off the parentheses there, and we end up with a statement saying not true or not false. Well, what is the opposite of true, right? Well, that's going to be false. And then or, what's the opposite of false? Well, that's true. Okay. Well, since we have the or statement here, I only need one of those statements to be true for this entire statement to be true. So therefore, this statement is true. Right? So, well, that was about it. I know that was really fast, but that's truth tables.